we have already Nathanaël and Asaf joining. Welcome. We really appreciate your initiative to kind of share your research. So the first session will be by Nathanaël, and he's the last year PhD student, you said, right, at Pompeu Fabra University. And Nathanaël will talk about evaluating LLMs in multi-session coding interactions. Please welcome, and I guess I have to stop sharing at this point to let you share.
So can you see my screen now?
Yes.
Okay, so thanks. So hello everyone, my name is Nathanaël Rakotonirina. So first I want to thank Professor Song Chun-ho for inviting me here, and I am glad to meet you all. So today I'm going to present this paper, From Tools to Teammates, Evaluating Large Language Models, Multi-Session Coding Interactions. This is a teamwork, so these are all the co-authors, and it took the work of all these people to get the results that we have in the paper. So in this paper, we envision a situation where a programmer has to interact with an agent, and it's a coding agent. And I think this kind of situation is these days, we can see a lot of these. Maybe, for example, you have the Claude Code and also Microsoft Copilot and also OpenAI Codex. So this is something that we see a lot these days. So here we're trying to evaluate the ability of large language model to track and follow simple coding instructions. So in this work, we present memory code. So memory code is a synthetic dataset, multi-session dataset that we use in order to evaluate the ability of language models to follow coding instructions. And I will go over the details now. So I'll start with some terminology. So we have what we call a dialogue. A dialogue is a sequence of session. In this example, for example, we have 10 sessions in this single dialogue. So what can we see inside a session? So in a session, we have a conversation between two people. For example, here it's Alice and Bob. And here, for example, Alice is greeting Bob. And in this scenario, Alice is a mentor, Bob is a mentee. Bob is a new employee at this big company, and they're going to work together. So throughout the conversation, Alice is gonna give coding instructions that Bob needs to follow. But also they have normal everyday conversations, like, for example, Bob asks what's the dress code in this company or things like that. So to introduce more terminology, so what we call fillers. So fillers are the everyday, non-code related information, like just everyday discussions. For example, here Bob asks, is there a dress code in this company? And then at some point, Alice asks, you can work from home once a week and things like that. But what we call instructions, or the actual coding instructions that Alice gives to Bob. So for example, here Alice at some point in session 2 says, when you write functions, you should end them with _n. And then at the end of session 2, Alice asks Bob to always include the string chx in the name of attributes. And these instructions can span through multiple sessions. For example, in session 10, Alice can also say, always end variable names with _z. So as you can see here, it is possible that former instructions are updated in later sessions. For example, Alice first asked Bob to end function names with _n, and then at session 10, Alice says Alice could say end function name with _b or something else. So instructions can be updated. So what we do is that at the end of the dialogue, we ask a language model to act as Bob, so as if the language model was the trainee, and then to generate a function. So for example, and these are very simple functions, we could ask something like, please write a function that sort the values inside a list, but you have to follow all the coding instructions that your supervisor provided. So by writing this function, the language model has to follow all the instructions, for example, ending function names with _n. And now, so do you have questions? Because it's important to get all the terminology and the setting before moving on to the result. But if this is all clear, I will move to the results section.
I just have a question. Which language model you mean?
So we are evaluating multiple language models, and I will get to that next, because this is like a benchmark.
So this is data creation now, right?
Yes. So this is
Okay.
just a data creation phase.
Okay.
And yeah. So how is this data generated? So we have these things we call seeds. First of all, to encourage diversity, we create personas for the mentor and the mentee. So things like, this is a very talkative person, or this person is very serious, or things like that. Next, we have names. We have a list of names like Alice and Bob. We also have the company names and things like that. Next, we have the instructions. So the instructions is just a list of coding instructions that are very easy to follow. Things like end variable names with something, or always put comments in your code, or things like that. So these are really simple instructions. Then we have a number of sessions. So in a given single dialogue, how many sessions do we have? So this could be, and then we randomly sample the number of sessions. Then for each session, how many coding instruction do we insert inside the session? So that's also one hyperparameter that we consider when generating the data set. We also have the number of updates. So for example, if we introduce an instruction, how many updates do we have? Like how many times do we update some instructions and things like that. And finally, we have the fillers. So these are just anything that is unrelated to coding, something like, for example, you can work from home during the week, or things like what happened yesterday. And to make the dataset more realistic, during the session, it is possible for the mentor and the mentee to refer to previous fillers. For example, if today they talk about work policy, it's possible that in later sessions they resume their discussion about work policy. So once we have what we call a template using the seeds, we ask a language model to generate a synthetic data set using this information. So this is controlled, and to ensure the quality of the data set, we manually evaluate all generated dialogue to make sure that the model didn't introduce additional information or didn't leave out some important information. And we were able to confirm that the quality of the data set. And we use command R plus when we generated the dialogues. So that's the dataset generation. Now I will move on to evaluation. So how do we evaluate models on this? We have 4 different settings. The first setting is what we call instruction. So this is more of a baseline. So what we want to evaluate with instruction is that given a language model that we want to evaluate, can they follow the coding instructions? So in this case, we just, in the prompt, we say, always end variable names with _n. And then we ask the model to write some function, for example, write a Python function to sort a list. And then we compute the score of a model. Can it follow instructions? And as you can see, we test multiple models ranging from Command R plus to open weight models like Llama 3.1 and GPT-4o, DeepSeek, the basic and the reasoning model. And as you can see, starting from some model size, most of them are actually very good at following the coding instruction. So here we want to show that the instructions are not difficult, and we even have a model that can perfectly follow all instructions. So that's the point of the first setting that we call instruction. In the second setting, which is supposed to be more difficult, the input to the model is not just a simple coding instruction, but actually a session. So a session is the multi-turn dialogue between the mentor and the mentee. So this should be more difficult than instruction because the model has to extract the coding instructions. It has to differentiate the coding instructions from the fillers. So it should be more difficult. But as you can see, we don't have a huge decrease in score. Sometimes it's just 1 point different. For example, from GPT-4o, it has 94% accuracy, and now with a session, it's only 93. So this is still very easy for the model. But it gets more difficult once we ask the model to ingest the whole dialogue. So here, history means the whole dialogue history, and we separated short and long dialogue history. So short means there are less than 50 sessions, and long means there are more than 50 sessions. But as you can see, we have a decrease, but the model is still able to follow some of the instructions in the short history. But as we have more and more sessions, the models, they start to struggle. And in particular, for example, GPT-4o, which is the best non-reasoning model, has only an accuracy of 30%, which is pretty low. And so this shows that it's not about the difficulty of the instructions, it's about following multiple instructions at the same time and also keeping track of the latest instruction. So that's it for the main results. If you don't have question, I'll move on to the analysis part. So now we ask, so here we plot the score on the y-axis and the number of sessions on the x-axis. And as you can see, for all models, as you increase the number of sessions and also you increase the number of instructions, it's becoming harder and harder for the models to follow. And for example, with sessions, with dialogue history with more than 100 sessions, the score is actually very low. Now we ask, why is this task difficult? Is it because the model struggled to extract the information from a very long dialogue? And by the way, all of these dialogue, they fit inside the model's context window. So this is not out of context, it's still very short. I think the longest dialogue can fit within half of the actual context window of the biggest model. So here, history is the usual long dialogue. Instructions chain, what we mean by instructions chain is that we don't provide the model with the dialogue, we extract all the instructions from the session. So here the input is just a chain or a sequence of multiple instructions, but as you can see, it's a bit better than providing the conversation, but the model still struggles as you increase the number of sessions. And this should be, I expect this to be very easy for humans to just follow a list of instructions, but actually it's really hard for those models to follow all these coding instructions. So as you increase the number of instructions that the number has to follow at the same time, it's starting to struggle. So in the last part of the analysis, we wanted to know if it's hard for the model to keep track of the latest update. So in the first figure, What we mean by update rank is that for a given instruction, an update rank of 2, for example, means that this instruction has been updated twice during the conversation. But it's a bit misleading. So here, if we look at figure 1, we could think that if an instruction is updated multiple times, the model has trouble keeping track of it because it decreases as the number of updates increases. But there is a confounder, which is the number of sessions. So that's why we control for that. And if you control for the number of sessions, yeah, like update, it doesn't affect that much the score of the number of updates, at least not until past some threshold. So I think here at update rank 7, it starts to decrease. We haven't tried with updates more than 7, so it's possible that once you update multiple times, it actually starts to have has an effect on the score.
So sorry, maybe I have missed it, but what's the update again?
So update rank, for an update rank for 3, for example, for a given instruction, it means that that instruction was updated 3 times. So for example, when it was first introduced, it could have been start variable names with A, and then it was updated to start variable names with B, and then start variable names with C. So in this case, it was updated 3 times. So that's what it means to have update rank 3. And then we gather the score for all of these updates. But it seems that for updates less than 7, it doesn't seem to impact on the score. So this means that the difficult part in this benchmark is actually keeping track of following multiple instructions at the same time. So before I finish, I want to go back a bit at the reasoning model. So this evaluation is done 0 shot, so we don't allow the model to do chain of thought or things like that. But for the reasoning model, so it can actually generate multiple chain of thought before producing the final code, and it seems to help. But here we can see, at least for DeepSeek R1, it is not enough to get a very good score. So even allowing the model to generate intermediate text doesn't allow it to perform really well on this benchmark. We haven't looked at the tokens that DeepSeek R1 generated, but we plan to do that. But right now we don't know, why is it that the reasoning model performed a bit better compared to the few other models? Because all the required information is already in the prompt, so there is no need to extract some extra information apart from the latest update, which seems to not impact the score at all. So yeah, so that's the end of my presentation. We can talk more later.
Yeah, thanks. Really nice content and presentation. Well, if there's any quick question, maybe we can do it now, but for longer ones, maybe we can keep them for later discussion. We have Saber is raising hand.
I have 2 questions, short questions. So the first one is that what are the criteria for selection of these models? So
okay, so here we wanted to, so we wanted to cover both closed and open weight model. So we have Llama, and then other models like GPT-4o, and I think Comment A is open weight. So we wanted to include the best model, and I think it's the best non-reasoning model, GPT-4o. We also wanted to include a reasoning model, DeepSeek R1. And yeah, so if it were up to us, we would include more models, but we have a limited computation budget. For example, we don't have a Claude and other things like that. One thing I didn't mention is that we tried retrieval augmented generation. Here, but it performs like the performance is in the middle of a history in an instructions chain. Because instructions chain, you can think of it as an upper bound on RAG, because it was able to extract all the relevant coding instruction, and RAG wasn't able to get all of them, so it has a lower performance.
And also in the analysis section, slide, I would say, the next one, or yeah, here. So I don't see, like, for example, DeepSeek V3 and also the other ones in the graph.
Yeah, so that's because we only added the other models during the rebuttal, so I didn't update this. This figure was extracted from the main paper, but we will update it later. But I can tell you that at least for the non-reasoning model, the trend is very similar.
Thank you.
Cool. So thanks again, and we can probably continue afterwards. And now the stage is for Asaf. Asaf is PhD student and at HU Jerusalem. And Asaf will talk about survey on evaluation of LLM-based agents. Super interesting. So welcome, and please go ahead.
Sure. Thanks. So, do you hear me well, and do you see my screen?
Yeah.
Great. So, this is a survey that we did in IBM with collaboration with Yale University, and specifically Arman Cohen, a professor from Yale. And this is the main figure that also will help us following the different steps that we had. So the motivation for the paper was that we recognize that there is some very narrow view of each agent and how they are evaluated. And as a part of a team that is focused on evaluation in IBM research, so we wanted to learn more about the current method, the trend, what are the shortcomings of current evaluation, so we can better learn how we advise other and how we develop tools that other can use to improve their agentic solutions. And based on that perspective, so we understand that there is a lot of different literature in each one of this subsection of different agentic aspect, and we wanted to survey that and to better understand each part. So this was the motivation for building that, and also we want to establish, and in that domain, in the LLM evaluation domain, we have a few already paper, and we very substantial and a lot of recognition. But in agentic, it's the first time that we start going in that fit. So we wanted to make a lot, bring ourselves together related to understand better the domain and how we come across it. So the main target audience for the survey was it's very broad, from agent developer that want to build better agent, so they need to find the right agentic solution, practitioner, a benchmark developer that want to know what is the current trend and how they improve and build better benchmark, and AI researcher in a whole. So we want to be very comprehensive in our survey. And indeed, the paper was well received. It got second place of the paper of the day in Hugging Face, and a lot of thousands of views overall, and a lot of connection afterwards. So let's start diving in. So agentic agent and agentic solution are, it's a relatively new, or got a lot of more focus after like the GPT, like it's become a lot of agentic solution. So it start maturing, and it's designed to solve problems that are complex, that a lot of time require multi-steps. And it's a different avenue of scaling the inference time. If reasoning, it's something that is happening through training by the RL training. In agent, it's less focus on the training part, but it's allow you to build complex pipelines that scale the inference time effectively. And also it's a lot of time rely on interaction with the world through function calling and tools. But the core backbone is still the LLM, but it's maybe shed a different light on the important dimension of the LLM as it serves as a backbone for those agents. So this is something that we also look into. And this shift also changed a lot, open a lot of new use cases that were less capable or less focused before the agent took off. So in that sense, there is a lot of new kind of problem that people trying to solve, and this give rise to the need of developing better and newer evaluation benchmarks. So this is the outline of the paper. So we have a few parts. We have the capability. So we recognize that as the LLM is very important and the basic capability of the agent to rely on that, there is a lot of core capabilities. So this is the capability in blue. It's mostly planning and reasoning, function calling, tool use, self-reflection, and memory. Then we have in orange the specific use cases that we recognize that are very important. So here we recognize web agent as one, software engineering agent that involves coding, but working on bigger directory of composed of code, scientific agent, and conversational agent. So those typically are like some of the categories that of agents that are used for, and accordingly there is benchmark developed for each one of them. And as we saw also a shift in LLM evaluation from more specific, task specific to more general, we also see a start of a baby steps in that direction in agent, as there is a beginning of more a generalist agent benchmarking that are not specific to one core capability, but to include those together and benchmark them in a broader sense. So this is on the all or in the LLM capability or agent capability. Then we also talked a bit about the frameworks that are a lot of time the baseline, the what allow the evaluation, and there is a lot of framework involved because unlike LLM, there is a lot of time environment, and the GEM or other framework are important for the evaluation of the agent. So in that sense, the framework play a key role in this pipeline, and also the evaluation they are provided to agent developer and agent consumer that want to understand better their tools. And finally, based on this broader view, we try to conclude by providing both the current trends that we recognize and then the few glimpse into emergent direction that we recognize. So I will break that down a bit step by step. So planning is mostly to decompose a task and to track the progress and develop solution strategies. There is a lot of such benchmark. A lot of them are not specifically designed for agent, but was developed beforehand for LLM. But there is a different focus when people thinking on LLM in the context of agents. So there is required different type of solution. function calling is a different LLM capability that is very important. So there is a lot of focus on function calling but also it started from more static ones, simple function calling, to more complex on long context with different requirement, with a lot of specs of tools. So there is a lot of dimension to play around with. And we see that they're becoming more and more complex. Self-reflection, essentially the ability to dynamically and continuously evaluate the model, evaluate its own output and then adjust accordingly. And memory, that is very important because a lot of time the context become much longer, is also related to what Nathanaël presented, that based on the memory of the previous interaction, the previous session, the agent need to provide the adequate solution, and also how you utilize the previous interaction in current one. And there is more short and long-term memory and external and episodic memory. So a lot of different dimensions that are being that are important for agent, and also they are targeted and evaluated. And also, if you feel free to ask, interrupt and ask, it's not to wait until the end. So you can raise your hand or just ask if you feel so. So in the agentic application-specific agentic and evaluation, we look into web agents. So their task is usually about navigating the web to accomplish some goal, the specific goal. So example, find a few Robert De Niro movie that are between the 2005 and 2010, and give me the one that have the best IMDb score. So that can be examples. So it requires some reasoning and also some additional requirement to uphold. So this requires from the agent not only to navigate the web, but also to do other stuff and finding the relevant information and filter it and adhere to the goal that the user state. So, and there is a lot of different web agent benchmarking, and it started from more static one to more dynamic environment to one that are less focused on visual cues to one that are more integrated and complex based on all kind of visual effect input. And even recently, IBM agent got the first place on web agent web arena. That is very dominant benchmark. So this is one type of application. Other type of application is software engineering. So most people know of SWE bench or SWE verified on different variation of that benchmark. So this one is based on the writing and debugging code, they maintain code, and there is different variation, but a lot of time it's involve how you do operation on bigger pieces of code, and not only the more LLM classic writing a piece of code. So this is the function you need to create and check if the LLM did it or not. More other application are scientific agent. So their goal is to come up with idea and also to conduct some research or to based on some paper to make a GitHub repo of the code. So a lot of time it's very complicated and complex task, and it's harder also to evaluate because there is a lot of how you can evaluate that this complex GitHub repo is adhere to the original paper. So there is a lot of effort put into those kind of solution, but the idea or what people envision in that field is that scientific agent can be the way to cooperate with agent and LLM as a whole to help to utilize the LLM and AI to solve, to collaborate in order to utilize them for scientific endeavors.
It's a really nice overview of the landscape. But time is kind of running out, so maybe yeah, we have to wrap up and move on to the discussion soonish. But yeah, you have some time.
Okay, so I will take a 5 and then
Yeah.
get into it. So generalist agents are more focused on combining those capabilities, as I said, regarding LLM. And there is the same idea of transition from a task specific to a more general type of agent. And there is embodied in the fact that agent and software engineering agent was shifting from more function to more complex one, and to more the one that are combine those different kind of capabilities and multimodal capabilities, and one that are based on freelance coding task. And so this one, the freelancer, is related to OpenAI and very complex and based on freelance tasks. So that usually people pay to get them done. And overall, what we learned from that is that we can recognize several key current trends that are important. So benchmark become more realistic, from more static website to more dynamic website, realistic one, from function calling, very toy example-ish, to real GitHub issues. For more benchmark also become more challenging. The example of code benchmark, that or paper scientific benchmark, you need to take a paper and create a GitHub repo of the code of that we created. So this one is very complex and usually require PhD level analysis. And also live benchmarking, it's because benchmark become outdated. So there is a lot of different iteration, and people come up with newer version or more complex one. So a lot of the benchmark have a version like the function calling one from Berkeley, or the Web Arena that a lot of the time have Web Arena, the more visual one, and other. So a lot of the time there is very few iteration of the benchmark. And we also recognize a few emergent direction regarding the agentic evaluation from. So basically most of the benchmark focus on success rate or overall success of trajectory. So either I succeed in the task or not, and there is not a lot of effort put into the recognizing the step that fail, or the intermediate cues, or where the agent fail along their trajectory. So this is something that is very important. We see only first step in that direction. Also based on a paper about AI that matters, AI agent that matters, there's analysis that most benchmark focus only on capability, but not on the cost and efficiency. So a lot of the time you can utilize it to build agent that are very inefficient, but still beat some leaderboard because they iterate a lot of the time. So this is a key problem in a lot of the current leaderboard. Also, scaling and automation. A lot of the benchmark are very small and very costly, so it requires some effort either by synthetic data to increase the amount of examples, or by utilizing LLM as a judge or agent as a judge appropriately to evaluate agent. So this is a new thing that we recognize that is in need. And also, finally, the safety and compliance. A lot of the time, agents are deployed in high-stake scenarios, and there is required from companies and elsewhere to ensure in a high level that they are safe, they are not operating in the world in unintended ways. So for that end, it's very important to evaluate those, and we see first effort on that direction, but not enough. So this is also some emergent direction with that we hope that we'll see more. And we also released recently the GitHub repo, and we track the newer paper that come out, and you are more than welcome to propose your paper or to add your paper, send us either by Git issue or by PR, and we will add it. And yeah, that was it. Thanks, and I will happy to answer a question or discuss it further.
Thank you. So let's jump into the discussion.
Sure.
Yeah, so please turn on your microphones and just say anything, right?
So I have a very general question. So I haven't read your paper, but can you tell me how the best models right now perform on most of these benchmarks? So do we still have room for improvement, or are they already very good?
Yeah, that is a very good question. I think that one observation that we made was that a lot of the benchmark, when they come out, there is very low results. So for example, the SWE bench, when they come out, it was the top model was about 1.4%. And after some time, the method they proposed was like down from 5%. I don't remember the exact number, but it requires some like long months until it starts climbing. And Devin, that was very point that made a lot of noise, was about 14-15%. And I think it's not only Sweven's example, but it's not only in that domain, but a lot of the other domain also. You see benchmark that are very low, and then gradually, because the rapid improvement of LLM is very very strong, and it's happened. It's really insignificant rate. So you see it become very high by few iteration, but still a lot of the benchmark are not saturated, and there is a lot of room for improvement in these domains.
Follow-up question. So, do you know what's the average lifetime of a benchmark lately before it gets saturated?
Yeah, interesting question. I didn't think about it, but I know it's a really big problem, because I heard in Europe the one that suggested the GPQA the benchmark, and he said that they invest tens of thousands of dollars and buy the conference itself related to song, and this endeavor of like talking beforehand. But the time that the conference got to the conference, it was already saturated, because 01 gets 70 on the benchmark in the PhD level. So it's kind of interesting. In agent, I think it's take a bit longer, because a lot of the time people create very complex and I think very bold kind of task. Because if you take a freelance task from some site that require that people will spend 32 grand to accomplish, so you better hope that it's something that is of significance, and it's very hard. So to expect the agent to achieve it, it's kind of a task. So a lot of the time it's a bit of a longer time span, but I think it's something that we are witnessing now. So it's hard to tell definitely, but still, I think it's a bit longer than it for LLM. But yeah.
And then I have a question for Nathanaël as well. So can you also answer the same question? Like, what do you think about the lifespan of your benchmark?
So before the reasoning model, I expected the benchmark to be hard. So we saw the result with DeepSeek R1. It was a bit better, but I think we need more than just chain of thought to get it. And we get saturated at some point. We can still extend it because it's synthetic data set. Also, it's hard to overfit on it in case someone wants to overfit, because we can just modify the instructions because these are very simple. So one possible extension we have been thinking about, for example, is to like use more sessions. So it's gonna be more expensive to evaluate, but it's gonna be harder. Also, I've been thinking about if-then conditions. So the model has to actually reason about the instruction, not just retrieve. So for example, when you write, when you write functions, then when you write functions about, I don't know, like something very specific, then use this instruction. But when you have this very specific situation, use this other thing. So the model has to reason over it. That would make the data set more difficult, but for the first iteration, we wanted to make it very simple, and the model struggled. But I would say we need more than just chain of thought but I would like to be proved wrong.
It seemed very related to long context because the session, and there is a very similar figure in same task, more token, if you know that paper. So
Yes.
that kind of like very degradation.
So it is
maybe it's a
related
different,
to the context, but in our case, actually having a million context won't help because the whole thing fits in like the current window of all these simple models. So extending the context to 10 million or using RAG, that they don't help in solving this specific benchmark for now. So this is a long context proof for now, because all the instructions are provided already. It is still difficult for a model to follow all of them at the same time.
For the talk by Asaf, I found it super interesting, kind of meta study of the benchmarks, the benchmarking behavior. So yeah, maybe it's similar to the question that Nathanaël was asking, but do they get used? I think like at the tail of the distribution, maybe there are quite a few benchmarks that are only used by the benchmark creators and not by the others. Do you have some idea about the general distribution here?
So I think that it's related to, like, even in LLM, there is a lot of task and how much specific or general some benchmark are. And for agent, a lot of the time, it's even more so, because I can develop some agent for specific tasks that nobody other than me, nobody cares for. Some solving, like I want the agent to book to add something to my calendar and specific to me and my calendar. So to benchmark it, it's to my use case, it's requires some additional benchmark or some other ways to evaluate it. So yeah, we saw that there is more general one and more specific one, and there is less focus on general method for evaluation of agent. For example, LLM as a judge is a general method to evaluate some output. It's not based solely on building benchmark. And so there is a lot not enough focus on that dimension, but I think it's something that will grow in time. But a lot of you can think about the current benchmark that exist is kind of representative of core abilities or type of behavior that are required. So a lot of the time, they kind of simulate broader behavior that are important. So in that sense, even if you don't necessarily benchmark on the specific task that you have, if it's a general agent and not very tailored to your task, it can be the same logic and same parameter or knowledge from the evaluation can be relevant for specific use case as well. So at least I believe. So that is other factor.
Yeah, thanks for the answer.
So on a related note, so if I want to publicize my benchmark, if I want many people to use it, do you have an advice on like what should I do to make it known to more people?
Your paper to the GitHub.
Yeah, add it to the GitHub is the first. And yeah, it's a good question. I think that that make it general in the sense that the output can be, the task can be relevant to others. So it's important. So if you find some tasks that people will appreciate the benchmarking on that task, so I think that this can get a lot of attention. I don't sure that it's representative, but for example, the paper bench from OpenAI, it was about taking a paper and make it to a Git repo of code that is reproducing the benchmark. So in that sense, there's a lot of effort on that. So it can be because it's OpenAI, but it got a lot of attention. So taking a lot of the time, it's very challenging and require a lot of people to build those kind of benchmark. And a lot of the time, they are not very big, but still they are, even though they're small, they represent well the task. So in that sense, building a small but really high quality benchmark for interesting tasks can be the way to go, I think.
Okay.
I think there's a lot of kind of sales involved nowadays.
And yeah.
And there are a lot of helpers. I think Hugging Face is a good example of kind of also you got the second place on the daily paper, right? Hugging Face. And Research Trained AI is also kind of one of the initiatives where we are trying to help the authors not worry so much about sales, right? Although, of course, you have to do the minimal sales, right? Like here, right? You're giving a talk about it. But we also try to kind of make this more public and reach out to more people, especially relevant people in our case. That's one of the goals that we have. So this question itself is very relevant and very core to our service. So if you have any suggestions or collaborative ideas, please let us know. We'll do our best to kind of serve your needs, right? And also to Asaf, you're maintaining this nice repository of evaluation of agentic AI systems. And I can imagine there can be tons of different collaborative ideas that we can push forward together. So
Sure.
for example, when we're building our communities, we also take a look at these kind of awesome list of papers quite a lot and survey papers quite a lot to kind of build this automated list. So in a sense, we are kind of maintaining this automated addition of the papers on a daily basis to this kind of survey list of cited papers, right? So yeah, we can probably find a way to kind of collaborate and have even bigger impact. We'll probably learn a lot from your experience and expertise.
Sure. Sounds good.
Yeah, so and then there's another session in a minute or two, so we have to unfortunately wrap it up. So thank you again for joining. Unfortunately, the session was a little short. But we can continue the discussion later on, offline, of course. And you can continue. So this session will be bi-weekly. So please feel free to join the next one as well. We'll continue to have this. And we are at a very early stage, so any feedback is welcome. Your feedbacks will directly shape the future of these events. And finally, this is being recorded, so we plan to put this on YouTube. There are some prior videos as well, but of course, yeah, you can opt out if you wish. So let us know, even at a later stage, if you wish. Yeah, so with this, I wish to close the session for today and thank the speakers again, Nathanaël and Asaf, for joining and giving a great introduction to their contributions. Thank you.